Good morning, community and friends. Welcome to the weekly dot.LA strategy session. My name is Annie Burford and I head the events here at dot.LA. Although we cannot convene in person, our journalists and events team are committed now more than ever to keeping the community connected, informed, and engaged minute to minute. Today's strategy session will feature dot.LA co-founder and executive chairman Spencer Rascoff, who will be speaking with Relativity co-founder and CEO Tim Ellis about 3D printing and manufacturing in the future of the new space race. Before we dive deeper into the subject and commence the discussion, a few housekeeping items. All attendees will be muted for the duration of the strategy session. The speakers will be displayed on video throughout the discussion. Audience engagement and questions are encouraged. Please feel free to submit any questions you have in the Q&A section. The recording of the strategy session will be posted on the dot.LA website by the end of the day. Please make sure to sign up and subscribe to the dot.LA daily newsletter to catch every headline. Without further ado, I'm excited to introduce dot.LA's co-founder and executive chairman, Spencer Rascoff. Thank you.
Hi, everybody. Thanks for joining today. And Tim, thank you for doing this. I'm really excited for this conversation. So Tim, welcome.
Yeah, thanks.
We met a couple years ago and I was blown away by the ambition of what you're trying to accomplish at Relativity. So why don't we jump in and have you describe the vision for the company, what started on literally on a napkin to today, and just walk us through the vision and mission of what you're trying to accomplish at Relativity.
Yeah, of course. I'm happy to share. So Relativity I founded back in December 2015. I was a propulsion rocket engineer working at Blue Origin, which is Jeff Bezos' space company. And I founded Relativity to 3D print an entire rocket. So we're actually using 3D printers to build literally a 110-foot tall rocket. Almost everything's 3D printed on that vehicle. And then the long-term mission is to one day 3D print the first rocket made on Mars. So we really see 3D printing as the most disruptive technology in our lifetime for building aerospace products. And Relativity found our company in order to build not just the rocket itself, but the actual factory and production process to build all of these products. So really think of it much like Tesla, where they built this new manufacturing technology with robotics and electric motors and batteries, but then they're really just selling the end-use product, like the Roadster, the Model S, and Model 3. And Relativity is that same thing, but for aerospace.
So let me get this straight, and for viewers and listeners, just to understand this, you were trying to 3D print a rocket or rockets to send things to Mars, but even more ambitiously, ideally, send the 3D printer itself to Mars to 3D print rockets to send things back to Earth. Did I get that right?
Yes, that's right. So yeah, the long-term vision is to 3D print the first rocket made on Mars. So that's in the spirit of seeing 3D printing as the inevitable future for what humans need to actually make things on other planets. So, backing up, I was at Blue Origin. I worked there, from when the whole team was only about 120 people up through 500. So really saw a lot of the early growth there as an intern and then full time. I was a propulsion engineer. So my job was to actually design and build rocket engines, and usually did full stack development. So started from blank sheet of paper all the way to the first working version, doing all the steps in between. And through that, I was the first user of metal 3D printing at Blue. So, we really thought there's no way this technology is going to work, but I was in my third internship looking to go full time. I really had nothing to lose. So I thought, all right, let's try to use metal 3D printing to make one part of a rocket engine, made the part and then tested it, and it actually worked. So then I thought, well, man, this has got to be the future. If it worked and was cheaper and faster by several, like an order of magnitude versus traditional processes, then this will be used everywhere. So when I joined full-time, I actually started the metal 3D printing division and worked with Jeff Bezos and the senior leadership team to bring metal 3D printing in-house to Blue. But then very quickly I saw, my co-founder was over at SpaceX. We had met at USC, so we're, I wouldn't say native Angelinos, but I feel pretty native at this point from our time at USC. And we really thought, well, if we can do one part of a product this way, why isn't the inevitable future that everything's not going to be made with 3D printing?
So we'll come back to
yeah.
We'll come back to LA and the role that that's playing in Relativity's growth in a moment. So you were experimenting with 3D printing within Blue Origin, and your partner was at SpaceX. Your college roommate and eventual co-founder was at SpaceX, and then he was also working on 3D printing at SpaceX, and then you joined forces to create Relativity to focus exclusively on 3D.
Yeah, that's right. So he was working on the Crew Dragon program, which is actually about to launch pretty soon. So he was a member of the propulsion team as well. Super Draco is their first 3D printed rocket engine component over at SpaceX. And so yeah, we both saw how the technology was actually mature enough to work for individual parts, but still less than, it's like a single percentage of a normal product is printed at best. I mean, really probably more like 0.1%. And so we are then building our rocket with 95% 3D printing. So almost everything's 3D printed,
So
which is very different.
Can you share your screen just to show people, for those on the webcast and not just listening in audio, what you mean by a giant 3D printer? And while you're doing that, and I should disclose, by the way, I'm an investor a proud investor in Relativity. And for me, one of the things that got me so excited and decided to invest was, I think you described the number of parts, just comparing a Relativity rocket with, say, a SpaceX rocket or some other rocket, the number of parts and the number of suppliers in the supply chain to create a traditionally manufactured rocket, and therefore the time and cost to create a traditionally manufactured rocket versus a 3D printed rocket. Can you just explain the differences and why it's so disruptive? The manufacturing technology isn't just neat, it's actually financially disruptive to traditional manufacturing.
Yeah, of course. So you're right. With 3D printing, since we're printing an entire rocket, we have about 2 orders of magnitude fewer parts. So 100 times fewer components than a traditional rocket. Really, if you look for the last 60 years, the way rockets and by proxy all aerospace products are produced hasn't really changed in the last 60 years. We're still using lots of manual, hands-on, human labor. We're still using very complicated supply chains. You may have thousands of individual suppliers spread all over the world for these kind of products. And then you also have factories full of what's called fixed tooling. So it's big capital expenditures. You walk in an aerospace factory and it looks really impressive. There's all these big, fancy looking machines. And if you've ever seen Iron Man or any movie, you see these huge, amazing factories. Well, it turns out that is a very manual process that's slow and super expensive to build products, which is why aerospace hasn't progressed as fast as I think people were hoping, or certainly I think is possible. So, we're building rockets with 3D printing. It's really an entirely new value chain and tech stack for building things. And it is 100 times fewer parts. We only have 2 raw metals for the entire rocket. So we go from thousands of suppliers to only a few dozen suppliers for the whole thing. And there's no fixed tooling. It's all controlled in software. And that software-driven approach is really what I think is the future.
So just advance a couple of slides to see the size and scale of what this 3D printer looks like. No fixed tooling, and it's all software. Okay, that's a great image here. So you can see the scale of this 3D printer. Because there's no fixed tooling and it's all designed in software, just describe what the impact that has in terms of the nimbleness and the ability to iterate as compared with traditional manufacturing.
Yeah, sure. So because of those factories of fixed tooling and the hands-on labor process and complex supply chains with traditional manufacturing, it takes about 2 years to actually have raw material come in the door or be ordered, and then produce a working rocket on the back end. And with our process, we're actually able to print a rocket every 60 days. So our target is to go from raw material to the rocket done in only 2 months versus 2 years. Wow. And then 60 days later, because it's all software defined, we can actually iterate and improve the product. So every 60 days, we're actually going to be able to make a better version and a better version. So the compounding rate of improvement for seeing the future happen faster is I mean, it's not even comparable. I mean, this really, I'm quite convinced is going to be the most disruptive technology in our lifetime when it comes to the aerospace industry, and really transforming it into something that's much more nimble, like software, and can actually be iterated to see better products happen faster.
So the raw material that starts, that you put into the 3D printer to then produce a rocket is what?
Yeah, so we have two basic raw materials. So our team, just for scale, is now about 150 people. We're only 14 people about 2 years ago, so we've gone through a sort of hyper growth over the last 2 years. Of the 150, we've got a material science team in-house, and we're actually developing a custom aluminum alloy. So it's an aluminum wire that is fed. You can see in this photo here, there's some blue lines and green lines. So the wire is actually fed through those lines up to the robot print head, which we've designed in-house. So Relativity actually builds this 3D printer. It's the largest metal 3D printer in the world, and we invented this technology. So about a third of our team is just developing the factory tools and 3D printers, as well as designing the rocket itself. And then that aluminum wire is melted. At the head, we use a combination of plasma and laser energy to actually melt the metal. And then wherever the robot moves, we can actually deposit in make structures. So I don't have a time lapse here. If you go to our website, you can see some time lapses, but back on this photo, that big aluminum tank on the left, that's actually a rocket fuel tank that we printed and took only about 10 days to manufacture, which is insanely fast. Normally,
I mean, this in a coronavirus era, this obviously begs the question: are you currently manufacturing? Are these robots currently manufacturing rockets with no employees in the building?
So we are. So we actually have all four. So we have 4 3D printers right now that are operating with only 1 person per building. So we do have 1 person in each building, but there's not more than 1 person in there. So we've got 1 person looking at 3 of the printers and 1 looking at this 1 printer, which is a separate building, and that's it. But otherwise, we're streaming data and telemetry remotely. And yeah, we started working remotely and are still making progress to first launch in the same year that we had before all this.
And so let's talk about that schedule. When is the first launch of a 3D printed rocket? And on what, when you say the real goal is to ship one of these 3D printers to Mars and then manufacture rockets to send things back to Earth, what is the time scale against which you're hoping to execute on that vision?
Yeah, sure. So first launch, we're expecting 2021. So we're on track for first launch there. So we actually have a launch site at Cape Canaveral in Florida. So this is the premier launch site. Relativity won access to one of the launch sites out there. We're actually only the 4th company to get a launch site at Cape Canaveral, which was a big achievement. We also have the infrastructure at NASA Stennis Space Center. So I've got an image of this. So we actually control about a third of all of the test sites at NASA Stennis Space Center exclusively for the next 20 years. So we've gone very heavy on infrastructure partnerships with the US government, which has helped us actually develop the rocket technology, and is a big sign of confidence, I believe, from the government that the tech we're doing is valuable, not just for launching payloads, eventually to Mars, but also for near-term goals like national security and telecom. So our market's really split into government customers, but also there's a robust commercial industry that's many $billion per year of market size to launch telecom satellites to space. So that's what we're really focused on near term with this first.
So I should make sure that that's clear to listeners and viewers. The business model here is to build these rockets at a disruptively inexpensive price, order of magnitude cheaper than others, yeah, and then ship primarily paid satellites from businesses and the government satellites and other things out into space at a disruptive price point. Is that fair to say?
Yeah. Yeah, exactly. So if you look at the market broadly, there's very, very large satellites that are the size of a school bus. And that's what big rockets like SpaceX's rockets and Blue Origin's rockets were designed for. And then there's very, very small satellites called cube satellites that are kind of the hot new thing. They're very disruptive, where you have constellations of hundreds of these satellites all networked together. But what Relativity is going after is a medium payload market that's really in the middle and is currently underserved, but the fastest growing market, with a total addressable market size in the many billions of dollars of unserved demand. And so that's why we're seeing success with customers. We're pre-launch, our launch is coming up next year, but we've already signed 9 figures worth of deals with satellite companies that actually bought our launches. At $10 million per launch is the list price, and we can launch about the size of a Fiat 500 or smart car. So it's still pretty big satellite, but in the middle, and that's a good entry point for us to actually develop this technology and 3D printing approach for this first rocket.
So this is not space tourism. You're not trying to send people into space like some of these other disruptors. You're trying to be a much less expensive commercial rocket business. In addition to confidence from the government, as exemplified by your partnerships with NASA and others, you've attracted a lot of financing. You've raised a lot of money from a lot of top-tier investors. Tell us a little bit about your funding to date.
Yeah, sure. So we've raised almost $200 million to date across several funding rounds. We just raised Series C, which was $140 million back in October of last year. So that was led by Bond. And Bond is the Mary Meeker's new fund. They're the Kleiner Perkins Growth Fund spun out, and they raised their own capital. It was also co-led by Tribe, which is also former partners from Social Capital, who led our Series A. So yeah, we've been able to attract a pretty broad base of funding. Obviously excited to have you on as an investor as well, and a bunch of strategic angel investors, and building that kind of community of diversified investors. We have growth investors. Allen and Company also invested, so we have relationships on the growth side. Other CEOs have invested.
Actually, describe the story of your first check into the company. And it's hopefully this will inspire others with your chutzpah. So go ahead, tell the story.
Yeah, sure. This is a good slide for that. So this is actually literally the actual receipt that we wrote the original vision of the company on. So this is a real photo, just kind of fun to look back on. When I left Blue Origin and SpaceX, me and Jordan left at the same time. We said, okay, we want to start this company to 3D print rockets, to launch satellites. That's the business case now, but we want to go to Mars. Let's be the second company that wants to go to Mars, because having, expanding possibilities of human experience is important. That's about all we had when we left. And then the very first email I ever sent, was 20 different emails. It was all different combinations of Mark Cuban's email address, because I was just an engineer. I didn't know anything about how to run a company or startup or venture capital or investing. So I just literally cold emailed Mark Cuban with guessing all of his email addresses. It turns out it's really simple. It's like mcuban@gmail.com, and it's not that hard to guess. And then he actually replied in 5 minutes. Originally, we were asking for $100,000 as part of a $500,000 seed round. And 10 minutes later, he said, "Okay, I'll actually just do the entire $500,000 seed round." So that was kind of off with a bang. And then that same week, we actually got into Y Combinator as well. So we were winter 2016, and just doing both of those with just 2 of us was a pretty crazy start. And then we actually raised Series A straight out of Y Combinator. So it's still just me and Jordan. That was about $10 million, led by Arjun Sethi at Social Capital.
Amazing. Let's move a little bit away from the product and talk about the scaling of the company. So I think you said
Yep.
2 years ago you had about 15 employees. I guess 3 or 4 years ago you were just a rocket scientist. Not an executive, not a business person, not a CEO. And now you've got 150 plus employees and a couple $100 million raised from investors. What was that? What was that growth like as an individual, and what have you learned about yourself as a CEO, and how do you scale yourself as the company changes through such a big change in such a short period of time?
A lot of getting your ass kicked. That's the honest answer. I really feel like you just have to constantly be learning. I feel like it's a good job for me. I love novelty. I love learning new things. I love putting on a bunch of different hats. But then you have to quickly change from that. I mean, you sort of see every time the company doubles, everything changes. That's a rule of thumb I've really seen actually play out over the years. So we've gone through, I don't know, 2 to whatever power doublings by this point. I mean, it's quite a number, going from 2 people to 4 people to 8 to 16 to 32. A lot of the processes you actually put in place don't work when you get bigger.
Right.
And so you have to not be precious about the things that you put in place, before, but you also have to not just totally throw it away as useless lessons learned. I think there is always this kind of traceability of scale, and that really is drawn together by having actual values as a company. We actually wrote our company values when we were only 5 people. So we rented a house in Malibu on the beach, which is really gorgeous, and did our first team offsite with 5 people and wrote our company values, because that was a big thing that was important to me. Besides an ambitious vision, was actually being a values-driven company that cared about audacity, relentlessness, and then wonder and humankind. And neither of those were mutually exclusive, because I really saw in aerospace, there are lots of ambitious, cool companies to work at where, you could work super hard and achieve amazing things, but it wasn't always tempered by having that focus on, humankind. And, that was an original vision for us too. So I would say the biggest learning for me was when we started hiring our senior exec team. They've been super fortunate. I'm super proud of the team we've put together. I think, that's probably one of the top things I'm proud of, more than raising money, or more than a lot of things, is really the team. Because at the end of the day, there's the people you're working with in the trenches to make this happen. And, I learned that putting aside my own ego is super important, and really hiring people that are bringing a lot of experience and knowledge and know what they're doing. And your job as a CEO isn't to always have all the answers. It's actually really to just be the conductor and figure out what the right mix of people are on the team to actually get things done.
I totally agree. Actually, Tim, if you stop sharing your screen, then the webcast will get bigger. So yeah, I mean, I absolutely went through that with my 2 startups of Zillow and Hotwire, figuring out how to change my style, my how I brought myself to work, how I spent my time and managed my calendar as the company scaled. And there's no question that key to succeeding in that and scaling is growing the team around you and surrounding yourself with great people and trying to motivate them and inspire them to do great work, and being humble and learning from them. And clearly you're focused on all those right things as a scaling CEO. I mean, what is it like to work at Relativity? How do you think people would describe working at the company?
Sure. I know one of the first things people have noticed, actually, strangely enough, is people laugh a lot. So I do think we have a lot of fun in the process. I mean, we're going after ambitious things. In many ways, I actually think some of the more ambitious ideas are more likely to succeed, even though they're far harder. And it's really because people actually want this to happen. I've really taken it to heart with what Y Combinator's original motto was of make something people want. In many ways, we've had to modify that, as a team, and I'll get to the team and culture part, but yeah, Y Combinator said make something people want. And early for us, we only had 3 months during the program to build a prototype of our 3D printer and get customer sales. And it's sort of difficult to fit in that time frame. But the thought is if people actually really want this feature to exist, then that's what we can build. Obviously, customers want to launch payloads to orbit, but beyond that, I think it's really important to inspire the next generation to do those ambitious projects and actually go after something that will really impact the future of humanity. Mm-hmm. But then, so with Relativity, I think that value does pervade everything. I think people work very creatively, since we are literally reinventing what the last 60 years of aerospace manufacturing looks like, while simultaneously building a rocket and working to launch satellites to space. We do have 2 major products, really, which is the rocket and then the factory itself. So I think we've just, again, been super focused on getting a very mission-driven culture. People are really bought into that mission. We have some of the smartest engineers in the world, frankly. I mean, it is a sexy product, so you certainly attract a certain type of engineer that wants to do something really cool while also having fun and impact. And I just think the mission really dominates.
That's so important. I mean, usually companies always talk about mission. I talk about it a lot in my podcasts and other places where I write. In your case, mission sort of has double meaning because you're on an actual mission. By the way, I don't want to let you get off the hook without answering a question from a while ago, which was, when do you hope to ship one of these 3D printers to Mars? Yeah. Is this like 10 years, 100 years? Like,
oh yeah, definitely not 100. No way. I definitely think 10 years is pretty reasonable, actually. And I'll get into the details of why. So with sending people to space, that's obviously what a lot of the world wants. I think human spaceflight is fundamentally important because just sending robots is great, but I think sending people to actually set up a permanent presence and have an interplanetary society, in my mind, would just reframe how modern society thinks of itself. Like in my mind, it's about expanding possibilities for human experience, emotions and art and politics. And if we were having this conversation right now and 1 million people were living on Mars, I think that would fundamentally change. Just like COVID-19, I think these big humanity-changing events actually do affect society, and that would be a big one. But then with 3D printing on Mars, we can actually, that's not us launching people. So we can actually start smaller and iterate. Like we could actually launch a very small version of the 3D printer at first, just to trial it on Mars. And even before that, you can actually simulate it's just the temperature swings, the atmospheric composition, the pressure, all of that we can actually simulate on Earth quite easily. Really, everything's easy to print on Earth as if it were Mars, other than gravity. So gravity is the one thing that then you need to account for. But with our 3D printer design, we're actually developing machine learning algorithms to take in the print data and learn how to adapt to uncertain environmental conditions. So that way those algorithms are the seed of what we would have when we're printing on another planet. So it can actually adapt to these unknown conditions. And you can start small and then go bigger over time. So I think within 10 years, easily, we could send the first version.
Amazing. A question has come in from a listener. Will Relativity test Stargate factory on the moon?
So we are looking into that. Right now, the moon and Mars are quite different as far as just the environmental parameters, but the technology does work on the lunar surface as well. So that's something we're looking into, and because of our relationship with NASA and other agencies in the U.S., it's definitely something that we're advocating that we could.
Now, should citizens be concerned that the government seems to have privatized space exploration and sort of pushed the burden and the opportunity to the private sector rather than keeping this in the public domain?
I only think people should be concerned that they need to keep doing it more. I think it's a total net positive. I mean, when you look at we're sort of in many ways in a space age 2.0. I mean, the first one happened in the 60s with all the developments leading up to Apollo, where the US and the world was figuring out how to build rockets and launch people into orbit for the very first time, culminating with landing on the moon. And then, there's a period of time which, for a lot of people looks more like a dry spell. I mean, we were still doing things. We had the space shuttle. We were building the International Space Station. The seeds of commercialization did happen during that time. But then really with SpaceX, emerging onto the scene and Blue Origin and Virgin Galactic, that was really wave, I'd call 1.0 of this new commercial space industry. And then Relativity, I believe, is wave 2.0. I mean, it really mimics a lot of the things you see in the internet, where there was, Netscape and kind of the late 1990s pre-dot-com bubble burst companies, which really created the first models of things. And then there was a second wave around 2006 to 2008, and all these other companies that really built upon that prior success. And many of those ended up becoming larger than the ones that were founded in the 90s. So, I think you're going to see the same thing in space, where we have a super experienced team. We've learned just as a society how to build commercial rockets, and now we're able to take it to a blank sheet of paper and start all over again with a lot of lessons learned and a new technology approach that's now possible due to cloud computing and other advances.
So a good question has come in about naming, something that all startups and all companies sort of struggle with in some ways. You named the company Relativity, you named your launch vehicle Tehran, and the engine Aeon, Aeon. Why did you choose those names?
Yeah, sure. I'll actually start with Terran, and then our 3D printer's named Stargate. So all of that stuff was named after StarCraft. So I'm actually not a big video game player for the last almost decade plus, but certainly growing up, I play video games. I'm from Texas, Plano. So if anyone's been there, there's not much to do. So I did do a lot of video games, and StarCraft is super fun. And so that's what it's named for. And it's sort of like, in StarCraft, the Stargate 3D print spaceship.
Right.
And our printer prints our rockets. And then Relativity is actually, when I was at Blue Origin, my girlfriend, now a fiance, Rochelle, is an artist. We actually almost started an art science gallery. So, I'm very passionate about art and creativity, even though I'm engineering by background. And we almost started this. It was going to be called Relativity Gallery. We actually wrote a business plan and almost signed a lease. And actually, that was the seed of thinking, hey, I like running my own things and kind of this entrepreneurial spirit. I just decided, instead of starting an art science gallery, to start a 3D printing rocket company.
All right.
I don't regret that.
So Tim Ellis, the rocket scientist who named his company after an art gallery and his products after a video game. Another question has come in. What makes someone's job application stand out at Relativity?
Yeah, so definitely a pretty clear, demonstrated track record of hands-on projects is really important on the engineering side. So I think, we don't look at grades or school pedigree that much, honestly. Of course, you see it, but that's really not the leading factor at all. I think a demonstrated history of actually leading or being deeply involved with projects, especially during school, is really important. So I guess that's a bit for younger engineers, but I just feel like doing hands-on student projects is way more like real engineering than school. School is important because you need the fundamentals to know what you're doing, and math and calculations and that good intuition. But hands-on is important. Other than that, we really look for, our values. So audacity, people that were wanting to be disruptive. They, were willing to kind of stick their neck out and fight for what they believed in. But then, they're also balanced enough where they know when they're wrong and they're low ego. You can kind of tell that from resume and then initial phone screens with people.
Have you hired and onboarded any employees entirely by video? So in other words, in this post-coronavirus world?
So we have. So we're in a very fortunate cash position just because of the Series C fundraise and where we're at with customers and the business. So we're actually hiring quite aggressively still. So I believe in the last, during coronavirus, we've probably onboarded or hired at least 12 people, I think. So we haven't slowed down at all. We actually did have our first person that we have never met in person. It's been all video, and she actually started at our Stennis Space Center test site, which, it's pretty awesome.
It's amazing. .LA has, I think, one or two folks also that have started, entirely virtually, if you will, and it's actually much better. It's much smoother and more normal than I expected. I never would have thought that would be possible, but this is the new world that we're living in. Somebody else asks, how does Stargate's 3D printing reduce the number of parts by 100x? So maybe just sort of describe a little bit more of the part reduction piece.
Yeah, sure. I wish here. I won't share my screen, but if you look at what a rocket engine looks like, you can just Google rocket engine or anything like that. You end up with this assembly that looks crazy complicated. There's lots of different components. Like, let's take the rocket engine injector. So this is a component that mixes both propellants together and then burns them, and that creates all the fire that comes out the end of the engine. So that singular component, the injector, normally would have lots of complexity, different fluid channels, pieces to mix all the propellants together. That single part may be 1,000 individual pieces. I've personally worked on projects where that is literally 1,000 pieces across 19 different supplier steps, and you have to ship all this stuff around and assemble bit by bit with lots of different manufacturing processes. So with Relativity, all of those parts actually fit in the size of our 3D printer. So we're able to redesign that whole part for 3D printing, which does look different than traditional. You can't just go from traditional to 3D printed design. It does look different, and that's one singular component. So all of the assembly, quote unquote, of that part is done digitally in the software file, and then you just print it.
So I'll describe it for those non-rocket scientists among us. Because you were kind enough to let me bring my kids to actually to your office, and my kids loved watching the 3D printer work. So if you can imagine that giant sort of robot arm type thing, it goes around and around and around, sort of pushing out this wire slowly, and it builds, and it goes up and up and up, so that after 2 weeks, boom, you've got a whole rocket that has been built basically by this sort of powder, kind of copper powder wire thing. And so, like, from my standpoint, it's basically just almost one part is what has produced this whole rocket. And it's just been produced from wire, from like one material. It's pretty extraordinary. And it runs 24/7, and as you say, it runs without people. There's one employee right now that's watching this on site.
I just think it's a big deal because it's like going from on-premise servers to cloud, or going from gas to electric. It's just a different value chain entirely. The factory looks different, the designs look different, the process is different, and we're creating that.
Somebody else asks, I've heard that the verification and validation of 3D printed parts has been a barrier to adoption in aerospace. What processes are you using to accomplish verification and validity reliably?
Yeah, sure. So that's definitely something we're very heads up on. Obviously, we have to make sure what we're doing is quality enough. I think, by the way, in the long run, it's going to be more reliable than traditional methods because of the fewer parts, the simpler supply chain, and it's a more digitally controlled process that you can collect a lot of data on. That's also very automated. So the chance of human error is much lower over time. We're not there yet where it's more reliable, but I do think that's the inevitable future and why we're building that approach. But then the straightforward answer is we do 3D X-ray of every single component. So it's different sort of test techniques, which we do while printing. We actually simulate all the prints before we print them to look for any potential trouble spots. Then while printing, we collect data. And then after we've printed, we've done thousands of samples where we correlate what those print parameters were and what the result was. And that all feeds back into a basically machine learning algorithm that has improved the print parameters over time. So we still X-ray every part. We still do what's called pressure testing and stress testing of every component before we actually go integrate it into a rocket. But yeah, that's a lot of what Relativity is just developing, is how to actually do this in a way that's equal, if not better, than traditional.
Amazing. I mean, it really shows manufacturing as software, not hardware. So it's the printing strategy not only unlocks the ability to have a disruptive price point, but it unlocks the ability to iterate much more quickly and change the design. So a number of other questions have come in around kind of company culture and process as you scale, which I think is something that a lot of listeners can relate to, even if they're in other industries, not aerospace. So just from my experience, what I saw through that scaling period was, as you say, Tim, the need to sort of maintain the same core values, but find new ways to communicate them at larger scale. So like, for example, let's talk about employee communication. So I'm guessing that you used to do, when you were 2 employees, 10 employees, 12 employees, 18 employees, you were doing probably very, very frequent all hands in-person communications. And then over time, you're probably shifting them to other methods. I mean, just can you give a couple of tactical examples of how you've changed, but also retained things as you've scaled?
Yeah, sure. So that's a great point. So yes, you're right. Certainly we used to do daily stand-ups and then weekly and then now it's monthly all hands with the whole company. So you have to, and that's just a constraint on time. So you really have to find ways to be super repetitive and simple in your messaging. And this is one of the biggest things I've found, is you really have to over communicate and you have to use the exact same words all the time, because what you're really looking to do, and this is another thing I've learned, you're not, as CEO, at first I thought, okay, I'm trying to say the right thing. Like I'm trying to communicate something that makes sense to me. But what I've realized is you actually want to put yourself in your employees' perspective, and you need to say it in a way that they'll actually understand.
Yes.
Like the communication is not for you to say it, it's for them to understand what you mean. So finding the words that resonate, and that gets harder with a bigger and bigger company, because now you've got 150 different perspectives that are probably going to interpret what you're saying all slightly differently. And so you just have to get good at making it simpler, and it actually sometimes feels less profound, perhaps, to say it in more simple ways. So a good example, is talking about our company values. When I explain the values, I always, every time I try to talk about, it's how to win and not lose our soul in the process. I say that exact sentence at all hands all the time. And I just want to repeat it over and over to where I'm almost sick of hearing it, because and I hear it, and how I know that's successful is then when I hear other people explain our values, they say, oh yeah, this is how we win, but not lose our soul in the process. And so now I can actually take that narrative and use it myself. So you want to just simplify your message, so that, almost think like you want to be able to tell your grandma and she can tell her friends and she can tell her friends with your company pitch. It's the same internally. How would
you know if you'd lost your souls? What do you mean by that?
Yeah, maybe that's getting a little bit to just what I've seen. Aerospace is a serious industry, and I think, how do you know if you lost your soul? Yeah, I mean, I think you just kind of look for since it is a big part of our culture that I can tell people laugh and like we're able to have really direct and candid conversations when things are going well or not going well. I think if that became, sort of where I saw fear-based management instead of management by inspiration, that's another thing I've tried to talk about a lot recently. And I've said a dozen times or so over the last couple of months is we should really seek to manage by inspiration, not manage by fear. And what I really mean by that is just, understanding it's a question, are you managing by pushing people or pulling people up? And in my personal, approach is really to try to inspire people that what we're doing is impactful and explaining why this needs to happen and we need to be the company to do it. I'm quite convinced that manufacturing will go to software. We're just the first ones to try it in this scale of ambition and but I think it has to happen, and convincing people of that.
There's no reason why this disruptive manufacturing technology won't come to auto manufacturing or, computer manufacturing or other types of other industries. You said something really interesting. I want to highlight for people because it's great advice for CEOs and leaders of all types, which is the need for repetitive communication. If you followed me around when I was CEO of Zillow and listened to everything I said, you would be so bored. It was like the same 5 things over and over and over again, just saying them to different audiences through different channels. Sometimes it's at a group lunch, sometimes it's on Slack, sometimes it's at an all hands, sometimes it's to partners. And it's just hitting the same messages over and over again in order for it to sink in, because employees are busy and they're not singularly focused on what you're saying at all times. So they get sort of bits and pieces. That's why it's so important to have this repetitive communication. I think politicians are excellent at this, actually. If you think of like some new messaging that, that somebody's trying to put out there, they put it out through one channel, and then they mobilize their proxies to put it out through all of their other channels. And these talking points sort of make their way out into the world. And you, as a consumer of information, you hear bits and pieces of it through a headline here or an Instagram post there or a tweet there. And like it starts to sink in to you because you're hearing the same messaging through all these different channels. It's the same thing as an employee, where if that repetitive communication is coming from your CEO and the rest of the leadership team, it starts to sink in. But it's actually very exhausting as a CEO and pretty dull. And what I have found is that generally the super high IQ CEOs sometimes have a really hard time with it because they just think it's unnecessary. Like, I mean, I once worked with a CEO who like could never get behind this concept because he was always like, what do you mean I have to explain to employees why we're doing X? Like, I told them that 6 months ago once, like they should get it, get there faster. Like, I get it. Why don't they get it? And you have to, as you said, like, you're communicating for their purposes, not for yours. So that repetition is so important.
Yeah, and that just triggered another quick tidbit that I've really picked up on, which is, an employee comes to, I've had this after an all hands where the title of the all hands is like company strategy. And I distilled it to 3 bullet points and it was super simple. And then I've had employees come up to me and ask, well, Tim, like, what's our company strategy? What is our strategy? I'm like, this whole presentation was about it. But what they're not asking that necessarily. They're not asking what the company strategy is. What they're really asking is, how do I fit into the company's strategy? Like, what's my purpose and meaning at this company? And I feel like it's the job of leadership. I wasn't this person's direct manager, but I relate it to their manager because it's really their job to create that purpose and meaning. You really want consistency where every single person can walk in the door and say, what am I doing today? And how does it add up to the company mission at different levels of the mission? And as you get bigger, there are more layers to the mission. Especially for us, we want to 3D print on Mars. That's the North Star. That is definitely not what we talk about on a daily basis. We talk about getting this first rocket to orbit, and we talk about what we need to do to achieve that. So
Tim, before
you just need to create this narrative. Yeah.
Before we wrap up, last question. dot.LA's mission is to shine a light on all the great innovation and entrepreneurship happening in LA. And I'm very proud and thrilled that Relativity is here in LA. Describe for listeners and viewers what why you think why is the company in LA, and what impact does that have on Relativity?
Yeah, sure. So, of course, we started in Y Combinator. Actually, originally we were going to be in Seattle, but since me and my co-founder went to USC, I love LA. I think LA just has this vibrant energy to it that is simultaneously laid back, but also still kind of intense, like in a fun way for me, and intellectually stimulating, and culturally stimulating. But then for LA, it's clearly the aerospace capital of the United States when it comes to talent, especially in the rocket industry. You've got a lot of leading private space companies, Relativity included in that, hopefully. And then, also universities with Caltech, USC, begrudgingly, UCLA, JPL, you've got satellite companies. So talent actually I found is a pretty important reason to locate your company somewhere. The second being customers. Like for us, customers are global, so we fly all over the world. It's an international market inherently because satellites go everywhere. So that's less important, but talent was by far the number one, and that's why we're here. But I see, I will say when it comes to capital raising, I usually get an Airbnb. I go live up in San Francisco and fly to New York a lot, and in LA too. But
Yep.
I think capital is not a reason just to be in the Bay. It's all about talent, in my opinion.
John Cook from GeekWire writes in the chat box here, Tim, you should have stuck here in Seattle, from John Cook. So thanks, John. Well, I'm thrilled that you're here in LA. It's actually a great reminder that there is a lot of hard tech here, including aerospace. Some people that begrudgingly accept that LA is becoming a tech capital frequently talk about streaming or direct to consumer, or maybe cannabis or e-commerce, these kind of like lightweight, sort of whimsical, aspects of tech or media. But you are doing hard tech. You are printing rockets to go to Mars, for God's sakes. And you're doing it here in Los Angeles. So, Tim, thanks a lot for the discussion. Good luck. We'll be rooting for you on that first launch in 2021. And thanks everyone for joining today.
All right. Thanks, Spencer. Yeah, and glad to be part of .LA.
Thank you.